In this video, I will teach you other functions with derivatives on the HP prime calculator, so we can extract the gradient of an expression. What is the gradient of an expression? It is the derivative of each component in x, y, and z. So we can extract this gradient using the gradient command. It is necessary to write the expression as if it were a vector, and the arguments must also be written as if they were a vector. In this example, we will extract the gradient of a component of the velocity field. Let's suppose I have a velocity vector with three components, x, y, and z component. The x component is given by the letter u, which is equal to negative 2 times x times y. I also have the y component, which is given by the letter v, and v is equal to y squared minus x squared. Enter. I have the z component of my velocity vector, which is given by the letter w, which is equal to 0. Stay with me until the end of this video, as I'm sure you'll find it super easy to extract this gradient. So, I come here now to my toolbox, go to calculation, bring the cursor to differentiation, and use my gradient command. I hit OK to call the command. Now I'm going to write the bracket, and here I will put the components of the velocity vector, u, y, or v, right? The y component given by the letter v, and the z component given by the letter w. So, here I have the three components of my velocity vector. I type a comma, call the bracket again, and write my arguments. What are they? They are x, y, and z, all set. Now I simply press enter. Remember that to perform this operation, I need to be in the CAS view. So it has already given me the extraction of the gradient of the x component of the velocity vector, represented by the letter u. So the derivative of u with respect to x is minus 2y. The derivative of u with respect to y is negative 2x. And the derivative of u with respect to z is 0. Right below, it gives me the extraction of the gradient of the y component, given by the letter v. So, the derivative of v with respect to x is negative 2x, the derivative of v with respect to y is 2y, and the derivative of v with respect to w is 0. And I also have here the extraction of the gradient of the z component of the velocity vector. Since w is 0, then everything is 0, right? Another operation of the HP prime calculator, which involves derivatives, is the vorticity vector. Let's suppose I have a velocity vector with three components, x, y, and z components, given by the letters u, v, and w, respectively. And now I will rewrite each component, remembering where the variables of the HP prime calculator are, Antonio. I can go here to Shift Memory, Variables of CAS, View. There it is. All the variables we wrote, look, u, v, and w. I can go back to the CAS view, no need to erase, just rewrite. So I'm going to come here now, I'm going to come here and write each component again. U equals 3 plus 2 times x minus y. I press enter. V is equal to 2 times x minus 2 times y. And GU is equal to 0.5 times x times y. I press enter. Easy, right? Now I can come here to my toolbox again. I will go to toolbox, go to calculation, differential, curved differential. So the curved differential is the vorticity vector. Okay, I will write my bracket again here. In my bracket, I will put the components of my velocity vector. Oh, what are these components? They are the component u, component v, and w, x, y, and z respectively, right? And here I will write in my argument x, y, z. I hit enter. So here, I have that my vorticity vector, its x component is 0.5x, its y component is minus 0.5y, and the z component is 3. Did you like it? Follow me on the channel for more videos on using the HP Prime calculator with a focus on engineering. Bye everyone.